And just like normal, y'all, if you have questions, please ask. Okay, so we are looking at 2.5, 2.6, and 2.7 this week. I sent you an email about how people did on the test. Go look at your test. I've given you instructions on how to get there. Go look at your test. If you have any questions, please email me. Let's get started. These are all fairly related to each other. We don't have a test till the beginning of March. And the one good point in being online is that we don't miss class because the roads are icy, or we don't miss information anyway. Okay, we're starting with 2.5, transformations of functions. We're going to be taking functions that we have here and moving them around. Let me see, is my light on? No, let me get my light on here. And let me dull it a little bit for you. Wrong way. Okay. If you printed this off, let me focus. If you printed this off before yesterday evening, I cleaned it up a bit yesterday evening. Good to see you too, Jennifer. Welcome to the hardcore group. Let's see. This is a linear function, y equals mx plus b. You know that's the same thing. F of x is the same thing as y equals. So this is y equals mx plus b. We're not going to spend much time here in this section in chapter 2. Here is y equals, in this case, 2. Again, we're not going to spend much time here on these two. Identity function, absolute value function, and the rest we are spending time on this time. And no worries, I know I'm going to go through these pretty quickly, but we're going to spend time on them. We're going to dive in. Identity function is this 45-degree angle where y equals x. So you've got the point 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Same thing going on down here. Negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. Identity function where the y and the x match. And it's just a diagonal line. Absolute value function we'll deal with today. It looks like a V. Whatever the y is, that's the absolute value of the x. So it just looks like a V that begins at the origin. The quadratic function, the parabola, y equals x squared. We'll go through that a lot. You'll be very comfortable with that by the end of this. Cube function, x cubed. This looks like a snake, and this looks like a snake charming snake. Here comes the snake out of the hat and up in the air. I mean, it's just a way to memorize it. But that's x to the third power. Square root function, I figured this looks like a guy's shoulder. Here's the head that we don't even see, and here's the shoulder if you're lying on your side. Okay, this is crazy. I'm back online. I'm going to start over on this recording. Let me start recording it. Let me see if I can. Yeah, I'm already recording it. Okay. This is the sheet, and it's good to see you all. It's good to see Jennifer and Brandon. We'll see how this goes. I think this will be a longer time because last time was at the end of my, I don't know, before we started a rolling blackout. Okay, these are the graphs we'll be working with for the next month or so. Linear function, y equals mx plus b. You know that one anyway. Let me get this thing going here. Okay. You know that one anyway. We're not going to work on that one. Y equals b, like in this case, y equals 2, a line that is at y equals 2 and is parallel to the x-axis. That one we will not be working with this time. This is the first one that will be new to us and we'll be working with during this month. Y equals x. So this is a diagonal 45-degree line through the graph, through the origin. We'll talk more about it later. All of these we'll jump into in depth. Absolute value function, y equals the absolute value of x. It's a v at the point of origin. Quadratic function, y equals x squared. That's a parabola, and we'll deal with that more than just about anything else of these functions. The cube function, y equals x to the third power. That's like a snake charm or snake. Out of the up into the air. Square root function, y equals the square root of x. That's like a guy lying on his side. Here's his head up here that you can't see, but this is his shoulder from his neck to his legs. That's his shoulder and his arm. That's the square root function. Cube root function is this guy, this snake, turned on his side. This is like a snake in the grass, the cube root function. And then later on, we'll deal with these two and we'll worry about them later. Okay, so this page, I corrected, I cleaned it up on Sunday. So if you printed it out beforehand, this is a much better cleaned up version. Okay, what we're going to do with these different functions is listed here. There are 4 things you've got to do that you've got to know how to do on these functions that we're going to practice in 2.5. The first one is a horizontal translation. That means the whole thing's going to shift left or shift right, shift on the horizontal axis. So x plus 2, remember I've been telling you that these next to the x's are liars? That's a liar. That means it's going to shift 2 to the left, to the -2 direction, and we'll play with that a bunch. That's what I've got abbreviated here as H. The next thing, ignore the horizontal, ignore all but vertical stretch. We're going to be doing vertical stretches on these. That means they're going to be pulled longer along the y-axis, so that 3 times the x means we're going to multiply the y values times 3 to stretch them, and that's what the S stands for. We're not going to be doing horizontal stretches. We're not going to be doing any shrinks, just a vertical stretch. And again, we're going to be doing them and doing them and doing them. I'll show you how to do them. The third thing, the R, is reflections across only the x-axis, not the y-axis. So just the x-axis. A negative in front of the function means it's going to reflect up or down on the x-axis. Or if you prefer, change the value of the y-coordinate to its opposite. I'll show you how to do both. And then the fourth thing we have to worry about is a vertical translation. That's a shift up and down. So there's the x piece. If we're going to shift it horizontally, that number is going to be right up close to the x, on the x function. But if it's outside of the x function, there's the x function, and there's a -5 outside of that radical, that means we're going to shift it down. This one's a liar to the left when it says +2. This one's not a liar. If it says -5, it means shift down. So we will play with this. You'll get good at it. But H serve is how I'm going to remember the order I have to do these in. And I'll go over them over and over and over. Okay. Let us get busy doing this. Let's see, that's that. Let me get to our second 2.5 worksheet. Okay, how am I going to do this? Okay, this will work like this. Okay. 2.5 worksheet. Number 1, use the graph of f of x, that's this little thing right here, just this little piece right here, to graph g of x equals that function, f of x, plus 3. And so what we're seeing that is on the x function, we are asked to add 3 to the x, but remember, this is a liar. If it's within the x function, it's a liar. So we're actually going to take the x and we're going to move it 3 to the left. 3 to the left. So each of these is going to have their x coordinate moved 3 units. So that's all we really need to do. I'm going to show you another method of determining this, but the first thing you need to, one way of doing it is just to say, this is part of the x function. It says plus 3. Whenever it's part of the x function, it's a liar. So I'm going to do minus 3 on the x. So this dot right here, I'm just going to pick him up. 1, 2, 3. Now he's right there. This dot right here, I'm going to pick him up and move him to the left. 3. 1, 2, 3. He's right there. Pick this guy up and move him to the left. 1, 2, 3. And he's right there. And now there's our new function, our g of x, was that f of x plus 3. We know that when it's on the x is always a liar. Another way of doing that, if you wanted to do it, was to draw yourself a t-table. Sometimes we'll have to draw a t-table, sometimes we won't. In this case, we don't. We know what to do. Move it to the left 3. But if you wanted to do a t-table, grab the original points. This was the first original point, and that's -4, -2. -1, 2, 3. How about -3, -2? This point right here, which was the second point, is 0, -2. And then this point is 2, -2. Okay, what this says is, again, it's a liar. Add a -3 to each of these x's. So we will transform this. We're just going to take each of the x's and add a -3. So we get -6, -2 to this first one. 0 and a -3 is -3, -2. And a -3 added to that 2 is a -1, -2. And now these are our new points. -6, -2, -3, -2, and -1, -2. So f of x is the original, g of x is the new. We've shifted it over, -3. Okay, let's look at another way of looking at this. In the h serve, this was the h, that was the horizontal shift. This is going to be a shift on the vertical. It's going to be the h serve, the last one. Put that up there. We're going to do the vertical shift. We're going to do the vertical shift on this one. So this is f of x, this mess, this set of 5 points. We're going to draw g of x, which takes these. There's the x, nothing happening to the x, not like in here, where within the parentheses there was a +3. So that was a function on the x. This is not. This is just, there's f of x, and then outside of that, sitting completely outside of the parentheses, outside of the function, is a -2. That tells you it's going to be a shift on the vertical, and it doesn't lie. So we're going to go down 2, or you're just going to do -2 on the y. You're going to believe it, a -2 outside of the function. So we're just going to take each one of these and just drop them down 2 on the y, because it's not part of this x. It's not mixed up in with this x, like this 3 is mixed up with that. So that's a liar. This tells the truth. So this is always on the y-axis. That's a vertical shift that happens outside at the back end of the function. So I'm going to take this guy, move him down 2. Take this guy, move him down 2. Take that one, move him down 2. And then connect the dots. And there we go. There's our g of x function. Again, if you prefer to do it as a t-table, you can do that. Let's take these original points. 1, 2, 3, 4. -5, +3. 1, 2, 3. -2, -3, -2. This one is 0, 0. This one is 2, 1, 2, 3, 4. 2, -4. And then 5, 3. Okay, this is, leave the x alone, nothing happening to the x, but we're going to drop the y down 2. So -5, drop the y down 2. In each case, add a -2 to this y, so we get a -4 there. Drop the y down 2, drop the y down 2, drop the y down 2, and we end up with this. Whether you read it off of there, which is, of course, a neater, cleaner, quicker way of doing it, or you do a t-table. Okay, let's see what we've got here. We have two things happening here. We've got something happening within the x feature, within the x function. It says -2. Remember, on the x, that's always going to be a liar. So the x is definitely a horizontal shift. You know, the x-axis is the horizontal axis. This says -2, so we're going to go +2. We're going to go to the right 2. It's a liar on the x. This out here at the back tells you what to do on a vertical shift and up and down, and it does not lie. So we're going to go +4 on the y-axis, or we're going to go up 4 on the y-axis. So our job here is to go to the right 2 and then up 4 from each of these points. So I'm going to take this point and I'm going to go to the right 2. That fulfills the x -2 part. And then I'm going to go up 4. Same thing here. I'm going to move him to the right 2. And then I'm going to move him up 4. To the right 2. And then up 4. And then to the right 2 and up 4. There we go. It's just these guys shifted to g of x, 2 shifts. These are horizontal shifts or horizontal translations. You'll see those 2 words used interchangeably, translations and shifts. They mean the same thing. All right, here's a new one for us. We have a negative out in front of the f of x. The negative, remember, well, you probably don't remember because it was brand new, but a negative means it's a reflection across the x-axis when it has a negative in front of the x feature. So, or importantly, the value of the y-coordinate, change the value of the y-coordinate to its opposite. So we have this as our f graph. This is our f function. We want to change it by reflecting it across the x-axis. So we're going to flip it up. This isn't a y-axis symmetry. This will actually develop x-axis symmetry. We're going to flip it up. What we're also doing, if you want to do it by building a t-table, and I will show you that also, is we're changing the y to its opposite. So this point, -1, 2, 3, 4, 5, 6, -3, that original point, -6, -3, if we're going to reflect this up across the x-axis, we're just going to change that y to its opposite. So -6, +3, right there. This guy, -3, 0, that's what he is in the original f of x function. If I'm going to change the y to his opposite, he's not going to change. 0 is still 0 when you change its sign. This point right here is 0, -1, 2, 3, 4, 5. So 0, -5. I'm going to change his y value to its opposite. And that is the same as reflecting this across the x-axis, flipping this up, taking this and laying it up on top using the x-axis as our line of symmetry. This guy is at 2, 0. Changing the y will not do anything to that point. And then finally, we got 1, 2, 3, 4, 4, 2, 3, 4, 5, 6. 4, negative 6. I'm going to change his y value to 4, 6. And now connect the dots. And this is g of x. That's our g of x. You can see if this was a mirror, it would be this. It would be the same thing on bottom as on top. When you have a negative in front of the function, you're going to flip this guy across the x-axis. If he had been there, then now he'd be down here. So that's our third thing. We've looked at 3 things to do here. When the x is a liar, and the x is always a liar, you shift on the horizontal. When you've got it out here on the back end, that's a vertical shift up and down. Here we combined them to the right and up. And then here we're looking at a reflection across the x-axis. Okay, so let's go to the next page here. I am concerned about losing power again because I feel like I'm going to be rolling all day long and probably for the whole week. So I think that I will stop these recordings at half-hour breaks as close as I can catch it or when it's convenient, and then come back in so I don't lose too much. I found out that earlier when I was recording, it lost that 3 minutes that I had at 8 o'clock. So I'm concerned about building up too much and then losing it, and I don't want to do that. So I will give you some warning on that, but each of these will be about 30 minutes or so. Okay, f of x is this mess. And then from there you can see we're going to our standard parent graphs. This is our last pretend graph. This is f of x. G of x is got a bunch of things going on. So when they've got something in front here, we're going to have to revert to our h serve. So let me write that up there. We're going to have to do this in that order. If it doesn't have something in front, and I'll go over this and over this and over this. If it doesn't have something in front of the x function, we don't have to worry about order. Order is not going to confuse us. But if it does have something in front, we're going to have to play that. So first thing I want to do is a horizontal shift. So I'm going to start with my t-table. You want to use a t-table anytime you've got a number in front. The first thing I'm going to do is the horizontal shift. That's here. Well, no, first let's record our points. Let's get our points recorded here. So this is -6, +2. This point is -3, -3. This point is 3, 2. And this point is 5, -3. Okay, those are the original points. Original. Now what I want to do is the horizontal shift, and that says x plus 3. Remember, this is always a liar, so this will be -3 on the x-axis. So let me take care of that. This is the h piece right here. From each of these x's, I'm going to subtract 3. So -9, 2, -6, -3, 0, 2, and finally 2, -3. I'm subtracting 3 on each of these x's. That's my horizontal shift. Next, I need to do a stretch. If I've got a number in front, and I do, I need to do a stretch. Let's go back and look at that just for a little bit of reinforcement. If you've got a vertical stretch, a 3 in front means multiply the y values times 3. So our 2 in front means multiply the y values times 2. So this will be our stretch here. -9, multiply the y value times 2. -6, multiply the y value times 2. 0, multiply the y value times 2. And then 2, multiply the y value times 2. There's our stretch. Next is a reflection. If we had a negative in front there, like we did on number 4, if we had a negative, then we would change these to their opposite. We don't have a negative, so we skip R in this case. We skip the reflection. And our last step is the movement on the vertical axis, and that says -1. This will always be a shift on the y-axis. So we're going to go down 1 or minus 1 on the y-axis. This is always a shift on the x that will come first. This will be a shift on the y that will come second. So let me take each of these points and lower them down 1. So -9, 3. -6, -7. Just keep adding in -1, 0, 3, and 2, -7. Okay, so this is the f function. We want the g function that has, this was the f, we did 3 things to it. We shifted it -3 on the horizon, that's the x. Then we multiplied the y's times 2, and we dropped the y's down 1. The only time you're going to be messing with the x's in these t-tables is right here. Everything else happens on the y. Okay, so -9, 3, that's out here somewhere. -6, -7, 0, 3, and 2, -7. So we end up with that. All right, let's start graphing. This begins what we will be doing in this class primarily. You'll have a few like this, but the rest of this test, the rest of this unit will be on parent shapes and shifting them around. Okay, let's remember H-serve. H is the shift on the horizontal happening right in here. Stretch would be a number out here. There is no number out there. Reflect, that would be a negative out here. There is no negative out there. And vertical shifting, vertical translation is this number right here. Okay, first thing you got to do is decide what shape this is. This is an x squared. Let me remind you of what that looks like. X squared is our quadratic, our parabola function. It looks like that. So I'm going to draw myself a little parabola right here to remind myself that's what I'm dealing with. And then what I know about that parabola, let's get him drawn in first. You don't know this, or you may know this. I don't know what you know. But the way to draw the basic parabola, and you won't have to draw too many of these shapes for sure. You need to know what they look like, but you'll be able to use multiple choice on the test, and you'll be able to use the graphing function that MyMathLab has that makes this much easier for you. But I want you to know that there's the base of this guy. That's at 0, 0. I'm going to put him there in the middle. Then the parabola over here scoots over 1 and up 1, right there. And that is the point -1, +1. And then we have a symmetrical piece over here, 1, 1, right there. I'm going to put him right there. So that's the little rat face, his 2 little beady eyes in his mouth, or his nose, I suppose, his nose. And then we're going to build his ears. We're going to go over 2 and up 4. So -2, +4, and +2, +4. Over from the origin, we go over 1, up 1, over 1, up 1, and then over 2, up 4. And there's this little mouse. Let's connect these cleanly, softly, gently. It's not a V there, it's a curve. And that's the graph of the parabola. I just want you, to know what that looks like. You don't really have to memorize those numbers, but it might be useful. I just want you to know it. Okay, because this does not involve a stretch or reflection, we don't have to draw t-tables like we did here. We're just going to do it. This tells us to take take the x points and go -2 to the left 2. That's supposed to be left. To the left 2. This one, remember, does not lie. This says go down 3 on the y-axis, so down 3. So each of these points is going to go to the left 2 and down 3. Or even easier than that, this vertex point of 0, 0 right here, that vertex point is now going to be -2 negative 3. We can read the new vertex point right off of the graph. Remember, this is always a liar. It's always going to be the opposite of the x. Negative 2, it's always going to be the same as what dangles out at the back end, negative 3. So let me grab a different color pen. And let's move our parabola. The vertex point, this point, is no longer at 0, 0. It's at negative 2, negative 3. So down here. And then you can build the parabola from there. Build as little eyeballs, over 1, up 1, over 1, up 1, and then over 2, up 4. From the origin, from the vertex point, over 2, up 4. And then draw that in. So each of these points, each of these 5 points of the parabola goes over 2, down 3, over 2, down 3, over 2, down 3. You can do that. I mean, you do what works for you. But to me, it's easier just to take the vertex point, drag it to this place. The vertex is no longer 0, 0. It's now negative 2, negative 3, and then just build them in. Even if we were doing this by hand, I wouldn't require these dots. I would require the shape of the parabola, the basic shape right there. It doesn't have to be that close to perfect. And you'll see on MyMathLab, you're just choosing. You're ABCing, or you're building off of their palette that I'll show you in a minute. So it's much easier than you trying to figure out where the points are. Okay, let's look at another one. Let's look at this next one. Okay, I'm at a half an hour, so I'm going to quit for now. I'm going to come right back in on a new recording. So let me stop recording.